All right, let's start with the first question. First question, I have a straight line, and I have a line over here, another line over here, another line straight up over there, and I am given the following. Given some kind of block here, and this is question 1. We want to find the value of x, where x is like that. And for each of these, we want to provide reasons, right? So we want to provide some kind of reasons for each of these questions over here. Let's start with this one first. Give it a go. Next question coming through. Got a straight line on that side. All right, so that's a straight line. And I've got over here x and 2x. Again, I need to find the value of x for this. Question number 3. Some kind of triangle. And I've got x over here, 70 degrees over here, and 130 degrees over here, and y. In this one, I want to find x and y. Each time you have to provide a reason, you get an extra mark. Right, if you know what the exact reason is. So try and remember anything that you can on the lines of the reasons for each of these as well while you're trying them. Question number 4. All right, give it a go. Let's see what you got. All right, let's go through each of these now. The first question here, we've got a straight line, and this square over here means 90 degrees. We know that a straight line, the angles will add up to 180 degrees. So the reason for this one would be angles on a straight line equals 180 degrees. So therefore, if I add all the angles up, so 90 plus 3x, because that part over there is x plus x plus x, which is 3x, will equal 180 degrees. Minusing 90 on both sides, 3x equals 90, and dividing by 3 on both sides gets you x equals to 50 degrees. Question 2, we've got 180 degrees on this side as well, because it's a straight line. And we've got 180 degrees on this side. If I add all of it up, it's going to be angles around the point. And angles around a point equals 360 degrees. So that means if I take 180 plus this part, which is 3x, it'll equal a revolution, 360 degrees. Subtracting 180 on both sides gets me 3x equals to 180. Dividing by 3 on both sides gets me x equals to 180 divided by 3 is 60. So in this case, x is 60 degrees. In this question here, we're not told about the sides and if they equal or anything. We're only given 70 degrees, which is inside the triangle. We do not know what x is, we do not know what y is. We want to find that. And we're given this outside angle, in other words, exterior angle. Now, the exterior angle of a triangle is equal to the sum of opposite interior angles. which means that the exterior angle 130 is equal to x plus 70. Opposite, can you see that? So x plus 70 equals 130. So x has to be 60 degrees. To find y, I could find it in two different ways. I could add these three angles up, and it will add up to 180 degrees. Right, so method one of finding y. I could say 60 plus 70 plus y equals 180. 130 plus y equals 180. So y equals 50 degrees. So this angle here will be 50 degrees. Method number two would be if you take y plus 130, it'll equal 180 degrees. So y will be 180 minus 130, which is 50 degrees. So y equals 50 degrees, and the reason for this would be angled on a straight line. The first one, remember, is angle in a triangle equals 180, and this one is the same as this one, angled on a straight line equals to 180 degrees, with a reason every single time. Over here we've got an isosceles triangle. That is actually a reason, or part of the reason. So therefore this angle must be equal to x. So these are base angles of an isosceles triangle, which are equal. And that's another reason base angles are a triangle. Isosceles triangle. An isosceles triangle. And then the last reason is angles in a triangle add up to 180 degrees. And so therefore 110 plus 2x equals 180. And so 2x equals 70. And therefore x equals 35 degrees. This is going to be angles in a triangle. The reason we get that to be x's base angles, and also the fact that it's isosceles. You could leave this reason out and just use that reason because isosceles is in it. Alright, an isosceles triangle implies that the base angles are equal. Okay. You could put base angles of an isosceles triangle equal. You could also write the word equal there as well. Alright, now let's do an example. So we try and bring a few of these together maybe. So over here I've got a triangle. Connecting like this. Alright, so I got all of these. X over here, Y over here, Z over here. I'm also told that, and let's call the center point O. So I'm given the following. I'm given that AO is equal to OB. Alright, so find the line AO and OB, and they're equal. That's part of it, right? I'm asked to find the sizes of angles X, Y, Z, and T. And M as well, small letter. Alright, with reasons. Alright, so we want to give reasons why or why they are that size. Give it a go, see what you got. Alright, here we go. Let's go through this one now. Okay, so for this one here, we got AO which is that side, equals to OB, which is this side. And we want to find the size of angles X, Y, Z, T, and M. X over there, Y, Z, T, and M. Let's go ahead and jump into. There are always many reasons and many ways to get there. You could start at any angle as well, and that could change your reasons along the way as well. So as long as you have a reason for why you're getting your solution, it's good. All right, and it's a valid reason. The first thing I'm going to start off is with X, and I can see that this is angles around the point. So therefore, X plus 160 equals 360. And so 2x equals 200, and x equals 100. So this is angles around a point. Once you get an angle, it's always ideal to write it in, because suddenly the other angles appear more easily to be understood as well. All right, so if I go to y, I can see y is part of this isosceles triangle, which means that this angle can also be y. I can write that down as well as a statement. I can say this angle, which is ABO, right? Can you see that? ABO, angle ABO equals y. And the reason it's equal to y is because of base angles in an isosceles triangle are equal. All right, so y plus 160 equals 100. It's equal to now 180 degrees. So angles in a triangle is the next thing to see. So y plus 160 equals 180 degrees. 2y plus 160 equals 180. 2y equals 20. And then y equals 10. And the reason is because of angles in a triangle equals to 180 degrees. Again, you can see I've got a statement, reason, statement, reason, statement, reason, as I'm building this picture. And once I've got that, I label it in there. I'm just going to write it in the outside. So 10 degrees to get in there. The next one, I can see these angles over here head up to 180. So t plus 45 plus 100 equals 180. 180 minus 100 is 80, minus 45 is 35. Angles in a triangle equals 180 degrees. Z plus 100 plus 20 equals to 180 degrees. Z plus 120 degrees equals to 180 degrees. So Z equals to 60 degrees. All right, and the reason is because of the same thing. Angles in a triangle equals 180 degrees. All right, let's write it here. So this one is going to be 35, and this one's going to be 60 degrees. Now, how do I find M? Those two angles are vertically opposite. 35 plus 20 equals M, vertically opposite angles. So therefore, M equals 55 degrees, and we're done. Let's just find the remaining angles and see if we can find the reason. If I had to find, or were asked to find this angle is also the exterior angle of those two angles, which is 10 plus 60, which is 70, plus 10 plus 45 plus 55. That's 125, right? So 125 degrees would be that angle on the outside there. Then I take 180 minus 125, and I should get 55, and it does, because the angles on the straight line. But just a note, that's the exterior angle. And if this is 125, this is going to be 125. What I'm doing now is solving the triangle, which means I'm finding every single angle. If I had to find this angle over here, it would equal also exterior angle. It will equal this angle plus this angle, which is 55, by the way, plus 55. So it'll be 110 degrees, also exterior angle of the triangle. Okay, just some extra tips in case I